Hello everyone, welcome to CSPN, the Calculus and Sport Programming Network. I'm your host Savannah Dowdy, and today we're covering last night's game between f of x and g of x. If we freeze for a second, we can see that the basketball moved in the equation f of x is equal to negative 1/2 x squared plus 3x plus 4, with domain restrictions on 0 and 7.123. That is our position formula for how the basketball was thrown. The position formula explains the position of the basketball in terms of time x. Now let's break this down. To find the velocity of the basketball, we need to find its derivative. The velocity explains how fast the basketball was moving as well as its direction of motion. Using the power rule, we can take the exponents of the function, multiply by the coefficient, and subtract 1 from the exponent power. Using that rule, we get f prime of x is equal to negative x plus 3. Equal the new equation to 0 and solve for x to determine the critical points or possible max and min. Maximum or minimums, which are found using critical points, are where the function reaches either its highest or lowest point. There are two types, local and absolute. Local max or min is where the function is highest or lowest at that point, but can be either higher or lower at another point of the absolute max or min. With f prime of x equaling to negative x plus 3, we can determine our critical points exist at x equals 3. To determine whether that point was a maximum or a minimum, we need to use the first derivative test. To do so, pick a value before 3 and after 3 on the number line, plug it in as x equals to f prime of x, and determine whether it was a positive or a negative. Since the basketball cannot move in a negative direction, it cannot go before 0, so we can use 2 and 4. The left side is positive and the right side is negative, so x equals 3 is a maximum in the function. However, we are given the domain restrictions, which we can use to solve the absolute maximum of the function. To do so, take the exponents and plug them in for x in the original f of x equation. Doing so, we get 0.4, 3 and 8.5, and 7.123 and 0.021. Since 3, 8.5 gives us the greatest y value, that is our absolute maximum. Furthermore, we can use the velocity function f prime of x to determine the acceleration of the graph f double prime of x. The acceleration of the graph is the rate at which the basketball's velocity changes. To find the acceleration, we need to take the derivative of f of x, or the velocity. Using the power rule, we get f double prime of x equals negative 1. Acceleration helps to determine whether the function is concave up or down. Since a parabola is always either concave up or down, this function will not have any points of inflections. In this graph, in particular, the function is concave down. However, to find the points of inflection, take double prime of x equals to 0 and solve for x. Similar to the first derivative test, use the second derivative test, plugging the values into f double prime of x. Here is an illustration of the position, velocity, and acceleration graphs put together. Next, we'll look at the best play in the g of x team. Here is a playback of their best throw, which follows the formula g of x is equal to negative 1/5 x squared plus 2.4x plus 2, with the domain restrictions of 0 and 12.782. That is the function for the position of the graph in terms of x time. Using the same power rule as before, the velocity is equal to g prime of x is equal to negative 2.5x plus 2.4. Equaling that function to 0 and solving for x, we get the critical point to equal x equals 6. Using the first derivative test and the endpoints, we can determine that x equals 6 is the absolute maximum. Next, we can find acceleration by taking the derivative of f prime of x to get f double prime of x is equal to negative 2/5. The graph is concave down. Here is an illustration of all three graphs in comparison. Each graph relates to the other in a special way. f of x has a negative slope, meaning f prime of x is decreasing. Since f prime of x is decreasing, f double prime of x is concave down. Furthermore, we can see where the basketball is speeding up or slowing down. To speed up, the velocity and acceleration must have the same sign, positive, positive, or negative, negative. To slow down, the acceleration and velocity must be different signs, positive or negative or positive. The velocity and acceleration are constantly negative, so the basketball is constantly speeding up. Here are some questions from our viewers at home. Find whether f of x or g of x has the greatest velocity at x equals 2 seconds. To solve this question, we must use the velocity equations we found before, the derivative of the position, and plug in 2 for x. After that, we can see that f of x has the greater velocity at x equals 2 seconds. Secondly, we have the question, calculate the displacement of f of x. Displacement is the difference between an object's final position and its starting position. To solve this, we must use the endpoints or our domain restrictions and our position formula. However, another way we can solve this is by finding the roots of the position formula by equaling f of x to 0 and solving for x. Doing so, we get x is equal to negative 1.123 and 7.123. Since time cannot be negative, our endpoint is x equals 7.123, meaning our displacement is 7.123 minus 0, which is equal to 7.123 meters. Our next question is, what is the average speed of g of x on the interval 0 is less than or equal to x, which is less than or equal to 8? To find the average speed, we must use the formula of distance traveled divided by time of travel. Firstly, we must use the domain restrictions as well as the critical point we discovered. With those values, we have to follow the equation, absolute value of g of 6 minus g of 0, plus g of 8 minus g of 6, which is equal to the absolute value of 9.2 minus 2, plus the absolute value of 8.4 minus 9.2, which is equal to 8 meters, which is our total distance. Then we divide by the total time, which is 8 seconds, getting 1 meter per second to be our average speed.
Thank you for watching. See you next week on CSPN.